Hello students, in this video we'll see examples of using the ratio test and the root test. Let's determine if the series, the sum, n goes from 1 to infinity, of e to the n squared over n factorial converges or diverges. So in this problem, our an is e to the n squared over n factorial. And what we'll do is we'll use the ratio test. So let's consider the limit as n approaches infinity of an plus 1 over an, which we know is the limit as n approaches infinity, of e to the n plus 1 squared over n plus 1 factorial over e to the n squared over n factorial. And we flip the fraction. This is the limit as n tends to infinity of e to the n plus 1 squared over e to the n squared times n factorial over n plus 1 factorial. Now n factorial over n plus 1 factorial, this term will simplify to 1 over n plus 1. And so we have, and of course we can expand out this exponential term. This is the limit as n tends to infinity of e to the n squared plus 2n plus 1 over e to the n squared times 1 over n plus 1. Now the e to the n squared over here will cancel with this e to the n squared. And so we'll have the limit as n tends to infinity of e to the 2n plus 1 over n plus 1 squared. Now we have infinity over infinity, so we can do L'Hopital's rule. And we'll get a limit as n tends to infinity of e to the 2n plus 1 times the derivative of the exponent, which is going to be a 2, over 1. And that clearly goes to infinity, which is larger than 1. And so the ratio test tells us this series will diverge. Ratio test implies this series is going to diverge. Okay, let's see an example of using the root test. Let's determine if the series, the sum, n goes from 1 to infinity, of 3 to the n over n to the n converges or diverges. Well, by the root test, what we'll do is we'll take the nth root of the terms in our sequence, which are 3 to the n over n to the n, n to the n. And so we see the n will cancel out over here, and so this will just be the limit as n approaches infinity of 3 over n. And this converges to 0, and since 0 is less than 1, we see that this series will converge by the root test. Thank you very much.